This is video 10C for the Year 7 Mathematics course. In this video, we're going to be covering the theory behind maintaining balance under the topic of equations. Specifically, we are going to explore representing equations using scales, how to maintain the balance on scales, how to lose the balance on scales, how to maintain balance in algebraic equations, and then we're going to cover some example questions. Along this journey so far of solving algebraic equations, we've been mainly focused on two different methods. The first method that we were introduced to was the method of trial and error, and then the second one was inspection. And so far, these methods have been great. They've been effective, we've been able to use them correctly, and we've all been good from there. However, with both of these methods so far have come some very, very strong limitations. If we consider trial and error, the biggest limitation of that is that we must be provided with a list of potential answers in order to even use the method itself. And then inspection, as we actually discussed in our last video, it can only really be used when the equations are so simple that we don't really need to do anything fancy. We can just look at it and know instinctively what the answer will be. So the question now comes, what happens if 1, we are not provided a list of potential answers, we can't use trial and error, and also what happens if the equations aren't particularly simple, then we can't use inspection either. So now we're going to be delving into a different realm of how we actually go about solving algebraic equations. And just a quick heads up as well, the next couple of videos are all going to be kind of like part 1, part 2, and part 3 of the same idea. And it's this idea that we are going to be mainly using throughout the rest of your high school career when it comes to solving algebraic equations. And the first step of this idea is something called maintaining balance. Now, the idea of maintaining balance is that it's actually a way in which we can manipulate and solve equations. Now, to introduce this idea of maintaining balance, we're actually going to be using a bit more of a real-life application in the form of a weighing scale. But we're not going to be considering a digital scale, we're actually going to be considering something a bit more old-fashioned in a balancing scale. Which, if you just need a bit of a reminder, looks something like this. I'm not the best artist, but just bear with me for now. Now, what I want you to imagine here is that right now, both of these scales are balanced because we don't have anything on them. But what happens if I put 3 identical blocks on each side? Then what's going to happen? Nothing's going to happen because both sides still weigh the exact same amount, and so therefore the scales are going to maintain their equal balance, or in other words, we say that the scales are balanced. And so from the perspective of an equation, the equation that would represent this situation is that 3 is equal to 3, because we've got 3 blocks on the left-hand side and 3 blocks on the right-hand side. Now, let's do something a bit different. Let's have the exact same situation, but now we're going to add on an extra 2 blocks to both sides. So if I quickly redraw this diagram over here again, but now we're going to add on 2 additional blocks to both sides. So again, what's going to happen? The answer is nothing, because once again, both sides have the exact same amount of blocks, and so therefore the scales are going to remain balanced. What would the equation look like this time? Well, again, on both sides we initially started with 3 blocks, but then we added 2 blocks to each side. So what we would say here is that 3 plus 2 is equal to 3 plus 2. Because we started with 3 blocks on both sides, added 2, and this equals means that we've maintained balance. Now, focusing on these two equations here, specifically this one and this one, what we can see has happened is that even though we have manipulated the equation to add 2 to both sides, the equation still remains true, because we of course know that 3 plus 2 is equal to 3 plus 2. So what we would say here is that the equation has maintained balance. Because even though we've done something to both sides of the equation still holds true. Alright, third and final scenario that we're going to consider here is what happens if we were to just add 1 block to the left-hand scale. Then what would actually happen in this situation? What's going to happen is the left-hand side is going to be heavier than the right-hand side, so the scale is more so going to look like this. And again, this is because now the left-hand side has more blocks than the right-hand side, so it's going to be heavier, pulling it downwards. And so if we were to consider the equation for this one here, the left-hand side, we started with 3, then we added 2, then we added 1. The right-hand side, we had 3, and then we only added that 2. And what we can clearly see here is that 3 plus 2 plus 1 is not equal to 3 plus 2, so we would say not equals in this case. And so in this particular situation, we would say that the equation has not maintained balance. And this is because we started with the equations that were both true, so this one here and then this one here, and then we went into an equation that is untrue. So we disrupted the balance of the entire equation by only adding 1 to the left-hand side. So how does this idea of the balancing of the weighing scales now transfer into the idea of balancing equations? Well, as we saw with these examples up here, we started with the equation of 3 equals 3, which of course we know is true. Then we added 2 to both sides, and the equation maintained balance. But then in the third case, we added an additional 1 to only one side, which then caused a disruption in the balance of the scales. So when we're talking about maintaining balance in equations, the idea is that whatever we do to one side of the equation, we also have to do to the other side. By doing so, we maintain balance. So what do we mean by this? It means that if we want to maintain the balance in an equation, then we can add or subtract the exact same number from both sides. Or both sides are either multiplied or divided by the same number. So with this first one here, where we say that the balance will be maintained if the same number is added or subtracted to both sides, just to give a quick example, if we started with the equation x equals 1, then if we added 3 to both sides. So if we do x plus 3 is equal to 1 plus 3, then here we would say that the balance has been maintained because we started with a particular equation and then we added the exact same number to both sides. The exact same thing would happen if we did a subtraction instead of an addition as well. Similarly, if we again started with the equation x equals 1, then we could do 2x is equal to 1 multiplied by 2. Because again, what we're doing here is we're simply multiplying both sides of the original equation by 2. So here, the balance is also maintained. Similarly, if we wanted to divide both sides by 2 or by 3 or by 4, the division would still work the exact same as long as you do the exact same thing to both sides. So that's effectively the idea of maintaining balance. And again, it comes down to this very, very simple notion that when we're dealing with equations, whatever you do to one side of an equation, you have to do to the other side as well. If you add or subtract a number from one side, you have to do it to the other. If you multiply or divide one side by a particular number, then you also have to multiply or divide the other side by the exact same number. And the reason why this is really important at this point is because when we maintain the balance of an equation, the solution does not change. And the reason why this idea is super important to us is because when we look at the next couple of videos, the idea of maintaining balance is going to be popping up quite a bit, specifically in how we can use the idea of maintaining balance to manipulate equations and then solve them. And this all comes down to the fact that when you maintain balance in an equation, the actual solution does not change. Alright, enough about that. Let's now get into a few examples of how we maintain balance in algebraic equations. Alright, let's first of all start off with the equation x plus 2 is equal to 5. And what we now want to do is we want to write the equation that results when we subtract 3 from both sides. Well, we're first of all just going to write the equation as we normally would. So we've got x plus 2 on the left hand side, and then we've got 5 on the right hand side. But now we are going to subtract 3 from both sides of the equation. And we can do this because we're doing the exact same thing to both sides. So now on the left hand side, what do we have? We have x plus 2 minus 3. We can actually now simplify this by performing the 2 minus 3. So 2 minus 3 is negative 1. So the left hand side is now x take 1. And then the right hand side, which is 5 take 3, is just 2. So this is the equation that results when we subtract 3 from both sides of this equation here. Second example that we're going to consider is we are going to be looking at the equation x take 5 is equal to 7, and we want to write the equation that results when we add 6 to both sides. So, how are we going to do this? We're first of all going to write the left-hand side and the right-hand side as normal, but now we are going to add 6 to both sides. And again, we can do this because we're just performing the exact same operation to both sides of the equation. Let's now simplify both of these sides. So with the left-hand side, we've got x take 5 plus 6. Let's perform these two operations here. So take 5 plus 6 is equivalent to plus 1. So the left-hand side is now x plus 1, and then the right-hand side, which is 7 plus 6, is 13. So the equation that results here is x plus 1 is equal to 13. Third example that we're going to consider is we are going to start with the equation x over 3 is equal to 2, and we want to write the equation that results when we multiply both sides by 9. Okay. So we're going to start off with the left-hand side and the right-hand side as we normally would, but now we're going to times both sides by 9. And again, this is appropriate because we're doing the exact same operation to both sides. The left-hand side will now simplify into 9x over 3. The right-hand side is now 18. But now we can actually simplify the left-hand side just by a little bit, because 9 divided by 3 is 3. So we now have 3. This x stays as it is. So we now have 3x is equal to 18. So this is the equation that results from this particular situation. And final example that we're going to consider is we're going to start with the equation 6x is equal to 18, and we want to write the equation that results when we divide both sides by 2. So, how we're going to do this one here. When we're doing division when it comes to maintaining balance, my suggestion always is use fractions. So, we've got 6x is equal to 18, but now we want to divide both sides by 2, which we're again going to represent via fractions. Now, let's just simplify this. On the left-hand side, we've got 6 divided by 2, which is 3. Then we've just got an x here, so the left-hand side is now 3x. The right-hand side is 18 divided by 2, which is 9. So the resultant equation here is 3x is equal to 9. And again, the really important thing to understand about all 4 of these examples here is that because with the operations that we did, we indeed maintained balance with both sides, it means that the original equations and the resultant equations are all going to have the exact same solution. What I mean by that is this equation and this equation both share the same solution. This equation and this equation both share the same solution. This equation and this equation both share the same solution. And then finally, this equation and this equation both share the same solution. And what I'm actually going to give you as a little bit of a mini task before watching the next video is quickly solve all 8 of these equations here and make sure that each pair have the exact same solution. Alrighty, let's summarize what we've learnt today. So in this video, we introduced the idea of maintaining balance in equations. When working with mathematical equations, the balance of the equation is maintained if the same amount is added or subtracted from both sides, or both sides are multiplied or divided by the same amount. That is, whatever you do to one side of an equation, you must also do to the other side. By maintaining balance, the solution of the equation does not change. Finally, we applied this idea to manipulate some linear algebraic equations. And that's it for now. See you in the next video.